My name is Carl Woodard. I'm a mechanical engineering student here at UT. This design project is on solar desalination. So we're effectively trying to take water that is too salty to drink, as that's a problem in a lot of places around the US, evaporate that and then condense it back down to drinkable drinking water. At first, we have our reservoir water that's in this blue bucket here. As it evaporates, we use this Fresnel lens to basically focus down the sun into a really hot spot. If you've ever used a magnifying glass, that's effectively what this is. So it gets it extremely hot to the point where it'll actually boil, which is way faster than how most solar stills work. So once it's evaporated, we have this solar panel that powers a fan. It flows through this condenser, which actually has cool water from the reservoir going through it to try and recycle some of that heat. Flows through this ducting and then comes out the end in case any is left over, and then anything that's condensed pulls down to our collector. Most stills that exist right now passively use the sun, and so while they work effectively, they're very slow. So our project is focused on making that move much quicker, which is why we use the Fresnel lens to get that temperature up really quickly. And so we're actually able to create vapor much faster than most other stills work. And so the idea is to be able to create the vapor here using the sun. The sun's really good at producing heat, so why don't we really focus that power and then use electric power to actually condense it. Overall, that is a lot faster than the passive stills that exist as of today. So we measured the total dissolved solids, and if you think about it, a Brita water can take your water from about 100 parts per million down to about 30. This brings it down to 10, so it's even cleaner than that. This was more, we wanted to use it as a proof of concept of how effective the Fresnel lens is creating vapor very quickly. And so our idea is that in industry, we could have a system where right now, they're all powered by some form or another. So if we can use the sun just to create the vapor and then use external power to condense it, those two combined on an industrial scale would work very quickly compared to conventional methods. Big takeaway I got from Singer Design is how we manage our scope, how we understand what we can accomplish, what the scale of what we're trying to do is, and then narrow down on that early on so that as we work, we're always keeping in line with what we can accomplish and what will actually be useful at the end of the project.